So let's start with the first session of today's symposium. Our next speaker is Professor Robert MAHLEY, Professor Emeritus and founder and senior investigator at Gladstone Institute's San Francisco, USA. Professor MAHLEY is also a professor of pathology and medicine at University of California, San Francisco. As founder of the Gladstone Institutes, Professor MAHLEY has more than 40 years of experience on supervising young researchers and guiding them to success. It is with great pleasure that I invite Professor MAHLEY to deliver his lecture, titled Guiding Young Scientists, Suggested Secrets of Success. Professor MAHLEY, the floor is yours.
Thank you very much. I appreciate the kind introduction. I hope you can see my slides, and I'm very pleased to have this opportunity to participate in this important program. Today, I will share some thoughts guiding young scientists, and I will discuss with you some suggested secrets of success for your consideration. First, I've been asked to discuss the concept of VW, and second, I will consider roadblocks that will inevitably occur in one's career and suggest how we might respond to those roadblocks. Let's begin with VW. About 25 years ago, I gave a talk to students, postdocs, and faculty at the Gladstone Institute's retreat. And the title of that talk was VW, It's Not a Car. Now, there was a young Japanese postdoc who was training at the Gladstone at that particular time, and he was in the audience, and that was Professor Dr. Shinya Yamanaka. Here, shown here in this photo that he actually has provided is the 1991 Volkswagen that I was driving at that particular time. V stands for vision, and in my opinion, one of the secrets of success is to have a vision for what you want to happen in your career. A vision is anticipating what might be if you stretch. A characteristic of a vision is that it is bold and it's risky, and I would suggest that it also recognizes the importance of contributing to society. Some might even call a vision an impossible dream. W stands for work. That is hard work. Now, there's an outstanding basketball coach in the United States who inspires his teams by teaching them to make each day a masterpiece and to never leave until tomorrow what can be done today. There's a famous ice hockey player from Canada who is quoted as saying, "You miss 100% of the shots on goal that you don't take." Envision your career and then work hard to achieve your vision. Now let's consider instructions for anyone with a vision. And these instructions were shared many years ago by a president of the United States. Now, concerning critics of your vision, and there will be critics, he said, "It is not the critic who counts, who points out how the strong man and woman stumbles. Credit belongs to the man and woman who is actually in the arena, who strives valiantly, who spends himself and herself in a worthy cause. The conquest goes to the person who knows the triumph of high achievement, and who, at the worst, if he or she fails while daring greatly, so that he or she place shall never be with those cold and timid souls who neither know victory nor defeat. Strive valiantly for a worthy cause. That's your vision. Dare to undertake the difficult, the impossible dream. Professor Shinya Yamanaka attributes his success to the concept of VW. Shinya said, and I quote him now, VW is a very simple message. He goes on to say that he didn't have a problem with hard work, and I can attest to that because he was working in the lab next to me. But vision was not so simple. He said, I had goals, but not a vision. His goals were to conduct valuable research, to write strong papers, to secure funding, to hopefully earn a senior post. Shinya went on to say, but when I told this to Dr. MAHLEY, he said, that's not a vision. It is simply a way to achieve your vision. Shinya states that his vision is as follows. My vision is to help patients, to develop new cures for patients suffering from intractable diseases and injuries. Now that vision over the years has expanded and evolved to using iPS cells in cell therapy to help the suffering patients with diseases and injuries. Well, let me share my vision as another example, and that was to contribute to preventing coronary heart disease and high blood cholesterol. The vision grew out of the fact that my father died at the age of 37 from a massive heart attack. I undertook my vision by studying a cholesterol transporting protein called ApoE. In fact, I have studied ApoE now for 50 years since I first saw that protein and began characterizing its structure and its function. That vision, my vision, has expanded now to contribute to preventing Alzheimer's disease. I'm working on ways to prevent the detrimental effects of a form of ApoE called ApoE4, detrimental to neurons. And as many of you probably know, ApoE4 is the major genetic risk factor for Alzheimer's disease. My vision then is to contribute to curing Alzheimer's disease. Will I succeed? I don't know. But I know I will strive valiantly and dare greatly. And this vision motivates me every day to get up, to go to work, to make a difference. Now let's go back to Shinya and his vision. It's all very easy, as you see at the top. Just create a bold vision and you work hard. Everything's going to work perfectly. Win a Nobel Prize. No way. That's not the way it usually goes. Every scientist faces roadblocks, hits brick walls, experiences speed bumps along the way. And here I've just listed a couple of Shinya's struggles or roadblocks. When he was at the Gladstone Institutes in the mid-1990s, his project was to express a factor in the liver of mice, a factor that he hoped would lower blood cholesterol levels. It didn't work as he had planned. The mice actually developed hepatocellular carcinoma, and that, of course, is not a good way to treat high cholesterol. A failed research project, you might say, yes, in a way, but no, it directed him into embryonic stem cells, cell proliferation, and differentiation. And then he went back here to Japan to begin his independent research. He began testing factor after factor to create the human and the mouse iPS cell lines. Most combinations failed. You see the number of years that it took, roadblock after roadblock. We will all in laboratories face difficulties. We will face problems. And so let's talk about how we keep a vision alive in the face of roadblocks. Roadblocks, brick walls, speed bumps. They're not fun, but they give us a chance to demonstrate just how badly we want to accomplish our vision. They really determine how committed you are to your vision. And I would suggest that any vision that is worth undertaking and is important will in fact face difficulties. Hepatocellular carcinoma, a combination of factors that failed, so forth and so on. Difficulties are inevitable. The secret, however, as a young scientist is, do you have the intestinal fortitude to push forward? I want now to give you another example of a distinguished Japanese scientist who had a lofty vision and how he overcame numerous roadblocks to develop a class of drugs that has undoubtedly saved the lives and millions of people from early onset heart attacks. Those drugs that he was involved in are the statins, and the scientist is Dr. Akira Endo. But before I tell you about his story, I need to give you a little background, a little science related to cholesterol metabolism, just very quickly. Cholesterol metabolism is regulated in cells and in organs through the uptake of cholesterol-rich lipoproteins by LDL receptors. LDL uptake mediated by ApoB, the ApoE is involved in another class of cholesterol-rich lipoproteins. The uptake of the cholesterol alters the level of the LDL receptors and modulates the activity of an important enzyme called HMG-CoA reductase. The statins modulate cholesterol synthesis and they lower cholesterol levels, and they do so by inhibiting this key enzyme step that involves HMG-CoA reductase, the rate-limiting enzyme in cholesterol biosynthesis. And thus, the statins block cholesterol production and secondarily increase LDL receptors, decreasing plasma cholesterol levels and decreasing the risk of coronary heart disease. Now let me tell you about Dr. Endo. Dr. Endo was a farm boy raised in rural Japan. Maybe many of you know this story. He was interested in science and medicine as a child due to the encouragement of his grandfather. Still, as a young man, he became fascinated with mushrooms and with molds. He was inspired by the work of Alexander Fleming, the discoverer of penicillin from the blue-green mold. Dr. Endo envisioned that extracts from fungi could be enzyme modulators and other important molecules. And along the way, as his vision developed, he developed an interest in cholesterol biosynthesis. His interest was heightened in 1966 when he came to the Albert Einstein College of Medicine in New York City. And he observed rampant heart disease in U.S. Citizens, which was enhanced, we know, by the high cholesterol and fat diet in the that the Americans were consuming and associated with high cholesterol levels. In 1968, he returned to Japan and he joined Sankyo Research Laboratories. He speculated that fungi could produce molecules that inhibit HMG-CoA reductase. And would this then decrease blood cholesterol levels? In the early 1970s, he examined broths from thousands of fungi, and he identified the first inhibitor of HMG-CoA reductase. And then he hit his first roadblock. His compound killed rats. And this was, of course, a definite setback. His vision, however, was expanded and it grew in his mind because the fungi were exciting. They produced molecules of biological significance. They inhibited HMG-CoA reductase. They regulated cholesterol biosynthesis, and they had an impact on coronary heart disease. That was his vision to develop and to prove. The first compound may have been toxic. It killed the rats, but he was not deterred. He would find a better molecule, and he did find a better molecule, and that molecule was called compactin. It was isolated from a mold on rice in Kyoto. The second roadblock. He gave it to rats, and it had no effect on blood cholesterol levels. At the time, this was a big setback. We understand now that rats just don't respond to statins, but at that time, it was really a difficult problem because Sankyo was not pleased, and Dr. Indo, however, was not finished. He had a friend in the lab next to his, and that friend studied egg-laying hens. Now, as you know, eggs are high in cholesterol, and hens have high levels of blood cholesterol. And when these hens were treated with compactin, the plasma cholesterol decreased by 50%. That is wow. At least it works in hens. Then it was also found that this compound also worked in dogs and monkeys. Another roadblock. Again, compactin was given to rats. It was not toxic. It didn't kill the rats, but the livers of the rats were filled with microcrystals. This raised a problem. But the vision remains alive in his eyes. In 1978, it was found that compactin inhibited HMG-CoA reductase in human fibroblasts. Very exciting, but will it work in humans? Will it have an effect on cholesterol? A friend of mine and a friend of Dr. Indo was Dr. Akiro Yamamoto at the Osaka University Hospital. He undertook a very risky project, and that was to give compactin to 5 patients with familial hypercholesterolemia. And lo and behold, the cholesterol in patients was decreased by 30%. Merck Pharmaceutical Company was impressed. Wow. And they began their own program. They identified a molecule that was related to compactin. It was called lovastatin. And then another roadblock. Compactin caused lymphomas in dogs in Japan, at least so we thought. Sankyo stopped the program. Merck puts its program on hold. But Dr. Indo continues to push forward. There were too many positive results to give up on his vision of finding a molecule from a fungus that could treat high cholesterol levels and CHD. What happens? It looks like the lymphoma problem was only a rumor. It was never published. We don't actually know what happened to that particular data. Goldstein and Brown repeated the study and found that there was no tumors, that it was safe in dogs. In fact, treatment of patients with severe hypercholesterolemia that followed demonstrated very, very few side effects of the drugs, dramatic lowering of the cholesterol level. Merck did a large study looking at the problem with tumors. There was no such problem, well tolerated. In 1987, the US FDA approved lovastatin as the first statin to be given widely to patients. As you can see from this story, I hope you've enjoyed this story, Dr. Endo maintained his vision, fighting through what I've listed at least 4 roadblocks that could have killed the development of these life-saving drugs. The end result is what I consider a miracle drug that's impacted the lives of millions of people in preventing death from early coronary disease. Now, I've tried to share with you just this very brief period of time. What I've learned over the years is maybe some of the secrets of success. So I suggest that you might want to remember VW. Establish a bold and a risky vision. It will do you well in your career, at least from my understanding. Anticipating what might be if you stretch, and willing then to work hard. Remember, there will be inevitable roadblocks, brick walls, speed bumps. Be willing to go forward and demonstrate how badly you want to accomplish your vision and determine how committed you are to that vision. And so I wish you great success onward and upward as your careers advance. Thank you.
Thank you very much, Professor Mahley, for a very insightful lecture. Now, I have one question here for you, and I hope you can give a brief answer, but it's a very interesting question. I wonder what you think about this. So I will read. Professor Mahley, I wonder if you have suggestions for female researcher success. We rarely hear success stories of female scientists, especially in Japan. Some years ago, we had a young female scientist who initially received a lot of positive attention, but at the end, her fame was dragged down so much by the media bashing. What do you think? What can you tell us about this?
This definitely is an issue that has to be faced. It has to be faced worldwide, and that is the encouragement, the advancement of our female scientific colleagues. It's unacceptable not to have the female scientists advance. There are large numbers that enter graduate school. There are large numbers that go into postdocs. They do not advance into the ranks of professors. We must change this. It is the same principles that I have just spoken about apply both to male and female researchers, but it is up to us, especially the male professors, to make sure that we do not allow the female scientists, our female colleagues, to not prosper.
Clear, thank you. I have one last question. Someone is actually asking how to build vision. It's very clear from your lecture how vision is important, but what is the best way to establish this vision?
As I believe you have maybe seen in the examples that I tried to give, 3 examples as to how a vision arises. It arises from personal experiences that begin with Endo and actually began with me in childhood. Shinya Yamanaka's vision came about with his own father suffering from a disease, and he could do nothing about it. So his vision was to make a difference in that way. My vision was to do something because my father died. Dr. Endo's vision was his passion, his fascination with molds and yeast and fungi. And then he went into the area of cholesterol metabolism. So you begin with all of your experiences that come together, beginning in childhood and proceeding. And you can see that they actually evolve. They take on different properties and different characteristics. I'm not sure whether I'm answering the question, but that's the best I can do at this point.
I believe you're stressing the notion of intrinsic motivation. This seems to be a very important driving force, if I understand your words correctly.
Well said, and I agree.
Okay. Professor MAHLEY, once more, I would like to thank you so much for this lecture, and we will be meeting later on for the panel discussion. Thank you very much.
Thank you.